Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Value your time and others' time. A very important advice for me and for everyone. The geometric distribution, lecture 1. A discrete random variable x is said to have a geometric distribution and is defined by its parameter p if it meets the following criteria. You can say these are the conditions for geometric model. Number 1, the repeated trials are independent. The number 2, the repeated trials can be infinite in number, meaning they are not fixed. Trials are not fixed. Number 3, there are just two possible outcomes for each trial. For example, success or failure. For example, win or lose, head or not head. The probability, number 4, the probability of success in each trial is constant. If you will observe these conditions, except the condition number 2, all conditions are same as for binomial distribution. So this is the different condition. This is the difference in fact between binomial and geometric. In binomial, the trials are fixed, whereas in geometric, the trials are not fixed. Means you repeat the process until you get your requirement. A random variable x that has a geometric distribution is denoted by this. Sorry. X follows geometric with parameter p, and p means probability of success. And the probability that the first success on the rth trial is given by this formula. X is equal to small r, q to the power r minus 1 and p to the power r, where p means probability of success and q is p complement. Q is 1 minus p. and the values of r start from 1. Rules to make the calculation simple. Now these rules are very important in order to make the calculations very simple and easy. Now when we have greater sign, then the answer will be q to the power r. And when we have greater or equal sign, then you just need to subtract 1 from r, like r minus 1. So you can learn these rules in this way. When we have just greater sign, the rule is q to the power r. When we have greater equal to sign, the rule will be q to the power r minus 1. When we have lesser equal to sign, then the probability will be 1 minus qr, opposite to this. If this probability is 0.3, then this will be 0.7, because these are two opposite inequalities. And when we have exclusive sign, like not equal sign, then the probability will be r1 minus q to the power r minus 1. Same thing, just power is minus r minus 1. So you can learn these rules in this way. Mode. The mode of all geometric distributions is 1. Mean. The formula of mean for geometric model is this, 1 upon p. And the formula of variance for geometric model is q upon p square. Now let's understand geometric distribution with this example and with some other examples as well. The geometric distribution. Example: plastic models of animals are given away in packets of breakfast cereal. Probability that a packet contains a model of a rabbit is 0.1. Consider probability distribution of x. Now this is very important. X, number of packets you open till you get a rabbit. Geometric model means you repeat the process until you get your requirement. So you need to open the packets until you get a rabbit. So there are possibilities. So what if you open first packet and you get your requirement? The answer will be 0.1, which is P. And let's suppose you get rabbit when you open second packet. First doesn't, second does. So for the first doesn't means 0.9, which is Q, and P. So you can write this as Q times P. Let's suppose you get the rabbit in the third packet. So first doesn't, second doesn't, third does. So the formula will be Q square times P. Therefore, you can write the formula of geometric distribution with the help of this example as Q power R minus 1 P. Why? Because you wrote, for third packet you wrote Q power 2 times P, like one less power. Conditions for a geometric model. I already have discussed the conditions of the geometric model. Now this example. How to solve this example with the help of properties. Sorry. So Jack is playing a board game in which he needs to throw a 6 with an ordinary die in order to start the game. Well, in order to throw a 6, the probability of 6 on a fair die is 1 upon 6. Therefore, Q will be 5 upon 6. Exactly 4 attempts are needed to obtain a 6. Now, this is part 1. With the help of properties, you can solve this as Q power 3 into P. Now, at least 2 attempts are needed. You can solve this as x greater equal to 2. Therefore, according to the properties, this will be Q to the power 2 minus 1, which is basically Q. He is successful in throwing a 6 in 3 or fewer attempts. So this will be 1 minus Q to the power 3. He needs more than 3 attempts to obtain a 6. For that, you just need to write more than 3, that means x greater than 3. So the answer will be Q to the power 3. So in this way you can solve this question. I just did this question with the help of properties. I'm leaving the calculations for all of you. You can just complete this later. Now, next question. I already have discussed the mean and variance. The formula of mean is 1 upon P and the formula of variance is Q upon P square. Sorry. Example 5.4. This is the example number 2 in fact. When I make a telephone call to an office, the probability of not getting through is 0.45. This is Q. If I do not get through, then I try again later. Let X denote the number of attempts I have to make in order to get through. Stating any necessary assumptions, identify the probability distribution of x. So this is basically geometric model. So you just need to write x follows geometric with p is 0.55. Part 1, x greater equal to 4. So according to the properties, x greater equal to 4 will be, this can be solved as q to the power 4 minus 1, which means q cube. And you know how to calculate mean and variance. So this is the formula of mean, 1 upon p, and this is the formula of variance, q upon p square. You just need to substitute the values. Example number 3. Identical independent trials of an experiment are carried out. The probability of a successful outcome is p. On average means mean. 5 trials are needed. So it's given mean is 5, and you know the formula of mean is 1 upon p. So p will be 1 upon 5. Find the probability, part 2. The first successful outcome occurs on the 5th trial. This is very simple. You just need to write q to the power 4 into p. Now let me show the answers. So p is, this is the geometric model with mean 5. So p will be 0.2. Sorry. And second part, let me solve the part 2 here. So it will be q to the power 4 times p, and q is 0.8 and p is 0.2. Make sure you give the answer up to 3 significant figures. I'm sorry. This is the example number 4. Sorry. A salesman sells goods by telephone. The probability that any particular call achieves a sale is 1 upon 12. This is P, 1 upon 12. Independently of all other calls, the salesman continues to make calls until one call achieves a sale. This is the geometric model. Of course, this is geometric, so X is the number of calls until a call achieves a sale. So this can be modeled by geometric like this. Now, calculate the probability that the call that achieves a sale is the 5th call made. So this is very simple. You just need to write x is equal to 5. So it should be q to the power 4 into p. Does not occur in the first 5 calls. Very simple. X greater than 5. So does not occur in the first 5 calls means x greater than 5. So according to properties, this must be q to the power 5. And you know how to find mean and variance. So this is the answer of part 1. And this is the answer of part 2. And this is mean. And here is the variance. Now let me solve few questions from past papers. A fair 6-sided die is thrown until a 3 or a 4 is obtained. This is your requirement. You know the property of 3 is 1 upon 6, or means plus 1 upon 6. So 2 upon 6, which means 1 upon 3. So this will be P. Therefore, Q will be 2 upon 3 on a fair die. The number of throws taken is denoted by the random variable x. And this until word means geometric model. You repeat the process unless you get 3 or 4. State the mean. So the formula of mean is 1 upon p. That means the reciprocal of p. So 3. Since p is 1 upon 3, therefore expectation mean is 3. Part 2, find the probability that obtaining a 3 or a 4 takes exactly 6 rows. Well, this is very simple. Exactly 6 rows means q to the power 5 into p, whereas q is 2 upon 3 whereas p is 1 upon 3. You should leave your answer either in fraction or in decimal. If you will leave your answer in decimal, then it must be up to 3 decimal places. I'm leaving calculations for all of you. Find the probability that obtaining a 3 or a 4 takes more than 4 throws. Now this is very simple. According to the properties, this will be q to the power r, meaning 4. Since q is 2 upon 3, so it will be 2 upon 3 to the power 4. 2 power 4 is 16 and 3 power 4 is 81, I guess. So you can leave your answer in fractions. If you want to give in decimal, then it must be up to 3 decimal places. 3 significant figures. Find the greatest integer n such that the probability of obtaining 3 or 4 in fewer than n throws. Now, according to the properties, fewer than n means this is less than 0.95. So, this is very simple. We know the properties. The property is 1 minus 2 to the power n minus 1. So, this chapter will be very easy if you will learn all the 4 properties which I have mentioned in my lecture early. So this will be q is, I guess, 2 upon 3. So 2, and this must be 0.05. Make sure you change the sign of inequality while cancelling negative on both the sides. So this is n minus 1 greater than 0.05. Now you have to take logs on both sides. And you must remember that logs of probabilities are always negative because of the nature of the logs. So n minus 1, make sure you change the sign of inequality when you will divide this log with this log, because logs are negative. If you will find log 2 upon 3, it will be negative something, it will be negative something, so you have to change the sign of inequality. Make sure you remember this. Now, I'm not using calculator. Let me check the solution. It's 7.39. You can check this in your calculator later. So this will be 8.39. Therefore, the integer value of n, the greatest integer will be 8. So this is the way. Make sure you change the sign of inequality here. While cancelling negative on both the sides, and then here while dividing this log with this log, because both logs are negative. And n is integer. Question number 7. Here are the answers of all 4 parts. You can check your answers later. Mean is 3. The answer of second part is this. This is the answer of the third part. 3 significant figures. This is also 3 significant figures. You can leave your answer in fraction, but if you want to give answer in decimals, then it must be up to 3 significant figures. And I already have explained this answer. Sorry. Question number 7. Next question. A pair of fair coins is thrown repeatedly until. Now this is very important. This will tell you that this model is geometric. A pair of tails is obtained. Now this is the requirement. So this is the sample space. When you throw 2 fair coins, then you will get these possible outcomes. So a pair of tails means 1 upon 4. Therefore q is 3 upon 4. Expectation is 1 upon p, therefore it will be the reciprocal of p, which is 4. Now part 2, find the probability that exactly 3 throws are needed to obtain a pair of tails. Now this is very simple. At least 3 we can solve this through the property. The property is q to the power 3 minus 1. Therefore, q to the power 2. I think it will be 9 upon 16. Next part, find the probability that fewer than 4 throws less than 4. So this is very simple. We know the property. The property is 1 minus q to the power 4 minus 1. So 1 minus q is 3 upon 4 to the power 3. I'm leaving answer for you. You can complete the question. Find the least integer n such that probability of obtaining a pair of tails in fewer than n throws. Now this is simple. Fewer than n throws, fewer than 4 throws, like both are same. So it would be, you can solve this part with the help of the previous part. 1 minus q to the power n minus 1. Now you know how to complete this. I just solved a question of this type in the previous example. So I'm just substituting the values. Minus q is 3 upon 4, n minus 1, minus 0.05. Make sure you change the sign of inequality while cancelling negative on both the sides. I'm leaving this question here. You can you just need to take log on both sides, and then you can easily solve this question. Now let me show the answers. Well, these are the answers. 4, second part is q square p. Let me check this. Oh, I'm sorry. I've made a mistake. Let me correct this. It was x is equal to 3. Let me do with this pen. Exactly 3. I wrote the question wrongly. So this will be q square p. Now q square is 3 upon 4 and p is 1 upon 4. So this is the correction. And the third part is 1 minus 3 upon 4 whole power 3. You can see this here. And the last part is n is 12. The answer of last n is 12. Now this worksheet is over. This lecture is over. I will discuss more questions. In fact, the solutions of more questions in my next lecture, inshallah. We should be positive. And I hope you will watch all the lectures with good concentration to understand the topics easily and correctly. Inshallah, I will make the next lecture and the solutions of some important questions soon, inshallah. Allah Hafiz.